Good day, ladies and gentlemen. This little presentation is going to be dealing with how a nerve generates an action potential, which is basically a nerve impulse. And to begin with, we're going to look at a couple of important terms here and characteristics of nervous tissue to begin with. Okay, neurons, have several properties. First one is irritability. And besides neurons, also muscle tissue to an extent is irritable. But irritability simply means this the ability to respond to some stimulus. And in this case, the stimulus is going to be anything from a flash of light to a sound to a pinprick. But the nerve impulse can actually respond to this. And then the second property you need to talk about, another term, is conductivity. Conductivity is simply the ability to transmit that impulse or move it from point A to point B. Now, as we begin this discussion here, we're talking about the plasma membrane as being polarized. A polarized plasma membrane is one that is at rest. It's not going to conduct an impulse. Here's what that means. In this picture here, we've got a plasma membrane right here, and we have sodium and potassium ion channels here. So we're allowing some ions to pass through this. ECF, extracellular fluid, ICF, intracellular fluid. So this is on the inside. If you look at this picture carefully, you notice that there's lots of ions in particular here, but the ones that we really need to pay attention to are sodium and potassium. Notice that on the outside of the cell, the sodium has a much higher concentration outside than inside. But the opposite is true for potassium. Potassium has a much higher concentration inside than out. And this is a polarized membrane. Now, this difference is great enough that when you look at the number of positive ions, there's much more positive ions in the extracellular fluid than there is in the intracellular fluid. Okay, so in other words, the inside of the membrane is negative. And the number that we'll be talking about later on is minus 70 millivolts as a difference between the electroconductivity of the inside to the outside.